Section 2.4 and 2.6 are on writing equations of lines and something called a best fitting line, which gets a little bit into statistics. First, let's just talk about writing equations of lines. There are different situations that you can be given, and we're going to talk about all three of those. First off, you could be given the m, which is the slope, and the y-intercept, which is b. If they give you the slope and the y-intercept, you should use slope-intercept form, which is y equals mx plus b. So again, if they give you the slope and the intercept, you should use slope-intercept form. I hope you're getting that the name kind of hints at what you should use here. If you're given m, which is the slope, and a point, you should use point-slope form. Again, if you get the slope and a point, point-slope form, which is y minus y1 equals m times x minus x1. The other situation you can be given, you could be given just 2 points, and that's it. In that case, you want to start off finding the slope, and then use one of the points, and use point-slope form. So let's do some examples. The first one is write an equation for the line that passes through the point 5,4 and has a slope of -3. We were given a point and a slope, so we're going to use point-slope form. And again, that is y minus y1 equals m times x minus x1. And we are plugging into the y1, the x1, and the slope. So if we fill that in, we have y minus our y1, and our y is 4, equals m, which is our slope, -3, times x minus our x value, which is 5. And then you simplify and solve for y. So if we simplify here, distribute our -3 through, and then add 4 to both sides, you end up with the equation y equals -3x plus 19. So in the next example, they say write an equation of a line that passes through the point -2, 3, and now there's two parts. First it says and is parallel to this line, and then it says if it's perpendicular to that line. Now they actually give us the slope here. That's why it's important to remember what parallel and perpendicular mean. If the line is parallel, it has the same slope, because they're never going to cross. And if they're perpendicular, that means their slopes are going to be negative reciprocals. So when it says the line passes through this point, and if we just start with A, and is parallel to this line, if it's parallel, that means it has the same slope. So they're giving you the slope. So they're giving you a point and a slope. You're going to use point-slope form, which we just used, y minus y1 equals m times x minus x1. So we just fill in this equation. We have y minus, our y point is 3. Our slope, we're doing A, and A says if we're parallel to this equation, so our slope is -4, because the slope is always in front of your variable. Then we have x minus our x term, which is -2. Now be careful with your signs. It should be minus -2. So it becomes x plus 2, essentially, because negative and a negative right next to each other become positive. So then we simplify, add our 3 to both sides, and that's our equation for A. So now if we do B, over here, part B says that now we're perpendicular to this line. So if we're perpendicular to this line, that means that our slope is going to be a negative reciprocal of -4. We're doing the same thing, except now we have a different slope. So everything's the same. Y minus 3 equals, except our slope. The negative reciprocal of 4 would be a positive 1/4. So if you distribute and simplify, and then add 3, plus 3.5 or 7/2 is the same thing. So that's your equation for B. Lastly, let's look if they give us 2 points. So they say write an equation of the line that passes through these 2 points. The first step is you always need the slope. So you're going to find the slope using these 2 points. So if we do our slope, y2 minus y1, 10 minus -2 over x2 minus x1, 2 minus 5. So you get 12 over -3 or -4 is your slope. And then you can use the slope in a point just like we did above and fill in our point slope equation. So I have y minus the y term, and you can pick either of these points. It doesn't matter which one you choose. Either way, if I use 5, -2 or 2, 10, I'm going to get the same answer. I'm going to use 2, 10 just because I want to, and because it doesn't have a negative, so maybe there'll be less errors. It really doesn't matter which one you choose. So if I do y minus y equals the slope we just found is -4 times x minus our x term, which is 2. And distribute and simplify. And add 10 to both sides. And that's your equation of the line. So if you just get 2 points, find the slope first, and then fill in your equation with either one of these points. It doesn't matter. The next example I want to go through has context around it, like a story problem, so you understand how to set up an equation in that case. So the problem is, in the school year ending in 1993, 2 million females participated in U.S. high school sports. By 2003, the number had increased to 2.86 million. Write a linear equation that models female sports participation. And again, when they say write a linear equation that models female sports participation, that means give an equation that tells the numbers right now and can possibly predict future participation. Whether you know it or not, this problem gave you ordered pairs. They said in 1993, the participation of females was 2 million. Those two numbers are paired together. That is an ordered pair. This is your input, your output, your x, your y. And then they said in 2003, it had increased to 2.86 million. So believe it or not, you have 2 ordered pairs, and all you have to do is find the slope and plug in just like we did above. So if we find the slope between these 2 ordered pairs, we do y minus y1, so 2.86 minus 2, over the change in x, so 2003 minus 1993. That gives us 0.86 over 10, which is 0.086. So we have our slope, and we can choose either one of these points, doesn't matter, to fill in our point slope equation. So I fill in y minus, I'm going to use the first value just so I don't have to deal with decimals. It'll be a little bit easier. So my y is 2 equals the slope, which we found over here, 0.086, times x minus, keep with the same point, I chose this one, so my x value is 1993. And then distribute and simplify. When I distribute these two, I'm going to get 171.398, and then add 2 to both sides. And that is my equation. The second part of the lesson talks about something called best fitting lines. These come up when we're talking about scatter plots. So here are 3 different scatter plots I have drawn. The best fitting line asks, where is the best fitting line that I can draw in between these dots that can predict my future dots. So what's the best line that can fit in between those? So before we get into talking about the specific lines, I'm going to talk about correlation. This first graph has a positive correlation. You can see that the dots that are formed look like they're going in the positive direction. And as x increases, y increases. So as my x values go up, you can see that my y values go up in the positive direction. So then the negative correlation is as x increases, the y values decrease. So as we look at our x getting bigger this way, we see that the y's aren't going up anymore, now they're going down. So as x increases, the y decreases. And if there's no correlation, your dots are just all over the place. There's no real correlation at all. So there's something called correlation coefficients. If the points don't lie near a line at all, like this last example over here, and there's no correlation, your correlation coefficient equals 0. If points lie near the line with a positive slope, which is like the first example I gave you, so if it looks like there's a positive correlation and they're really close together, then your correlation coefficient is 1. And just the opposite, if they're all really close together and they're going in the negative direction with a negative slope, then your correlation coefficient is -1. So I want to do a couple examples to kind of put these in perspective for you. So tell whether the correlation coefficient for the data is closest to -1, -0.5, 0, 0.5, or 1. So we're looking at a scale from -1 to 1. We're supposed to tell where the correlation coefficient is closest. Let's start with C because C is the easiest one. You can see that all these dots are really close together, and that if you drew a line through them, they would all be really close to that line. And this line is positive because as x increases this way, our y is also going up. So this is a positive correlation, and it's really close together. And up here we said that a positive correlation, your coefficient is 1. So we would say that this is closest to 1. So A over here looks like it kind of has a negative slope going on. The dots could kind of form a line. So it would be a negative correlation, but it wouldn't be -1 because they're not really close together. So this would be close to a -0.5. If we look at B here, this has no correlation at all. The dots aren't going in any direction. So our correlation coefficient would be 0. The coefficient just tells us how well does the line fit. If it's 1, that means the line fits really well. If it's 0, that means a line wouldn't fit this at all. So what you can do is actually write a best fitting line, an equation, for a scatter plot. So what we're going to do is approximate a best fitting line for example C. To do this, all you need is 2 points off your graph. So whatever graph you're doing it on, just grab 2 ordered pairs. So if I look at my graph right here, we're going to use this graph, example C. It looks like I have a pair right here, 1, maybe 27, you can approximate, and 2, maybe 30. So because you're choosing points off the graph you're approximating, your line might not be exactly the same as everyone else's, which is okay as long as it's close. So what you're going to do after you get the 2 points is find the slope. So I did my y, change in y over change in x, and it looks like I have a slope of 3. Then once you have your slope, you fill in your point slope equation, and I can choose either point, it doesn't matter which one I choose. I'm going to pick the first one, use my slope of 3 that I just found, and simplify. And after I distribute and simplify, I'm going to get 3x plus 24. So that is my best fitting line. That means if I go to graph that line, it's going to be really close to all of my dots. This is the last example that I want you to do in your notes.